Okay, algebra kids, this is section 8.4. I gotta turn my screen on here in just a second. This is section 8.4, distributions of data. Yesterday we did the histogram part of it, the front side, and we've got 3 exercises left, including some talk about some box and whisker plots. But before we do that, we're gonna do example 3 first, okay? Before this video, the 6th period class and I went ahead and put these in order from least to greatest, so this video doesn't take forever. So if you want to pause, I've got both of those up there right now. For example 3, if you want to pause and write those down, you sure can. I skipped a couple, so 67 should fit in there, 73 should fit in there, but otherwise we've got the rest of them all ready to go. And in example 3, we are comparing the 2 test scores, chapter 3 test, chapter 4 test, using a box and whisker, or using a histogram, okay? So when you compare using a histogram, you want to make sure that you have the same units going on, okay? So I don't want to label my axes different on one histogram versus the next. I want to label them exactly the same. So we've got to decide for both of our data sets what we want our ranges to be, right? So the lowest one is in the 60s and the highest one is in the 90s, all right? We could do 60, 70, 80, 90, but that only gives me 4 bars to compare. And usually a histogram has like 5 to 20 bars, okay? There's some of them can get a really lot of bars. So I feel like we should separate it into more than just 4. 60 to 64, 65 to 70, is that what you're saying? Okay, so I'm going to separate this out. There's my broken graph. We're going to start the first one at, I'm going to turn my graph sideways, 60, 64. We'll do, okay, 60 to 65. Oh, how are we going to do this? Because we don't know where 65 fits exactly. We're going to, let's label it this way. I'm going to do, this range is 60 to 64. I'll label them inside of here. Okay, this range is going to be 65 to 69. This range is going to be 70 to 74. This is going to be 75 to 79. 80 to 84. Do you guys see the method of my madness here? 85 to 89. 90 to 94. I'm labeling like the inside now instead. 95 to 100. Okay, and I'm going to do the same thing for this one. Here's my broken graph. 60 to 64. 65 to 69. 70 to 74. 75 to 79. 80 to 84, 85 to 89, 90 to 94, 95 to 99. Wait, yeah, this should be a 99 here, not 100. 99. Did I do all that right? Maybe? Okay. So rather than labeling each one of the breaking marks, we'll label the actual range that goes in there, 60 to 64, 65 to 69. We can't overlap, so you wouldn't want to go 60 to 65, 65 to 70, because then you don't know where 65 fits exactly. So you've got to kind of cut it off a little bit different than that. Okay? And since we have these in order, this should make the next process really, really easy. We'll say, how many is the most category? We've got a lot of 74s. We've got like, we've got probably a ton. Okay, let's do, I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we'll do the same here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I don't know, there's probably more than 12 in that one category that has a bunch of 74s. Okay? I just did 12 up on the side, we might have to add more to that. We'll just go all the way up into space up here. Okay? So 60 to 64s, let's start with the left side graph. 60 to 64, there are only 2 I think I see. Is that right? I'll fill these bars in and then you tell me when I do it wrong. 60 to 64. Okay, 66, let's see, 65 to 69. There's 3 of them. Is that right? I'm not going to bother shading my graph in. 70 to 74. I see 4 of them. So one more than that. 75 to 79. I see 5. Are we just going like up by ones every time? 2, 3, 4, 5. Okay. 80 to 84. 1, 2, 3, 4, 5, 6, 7 this time. Going up 2 more. 85 to 89 is 5 numbers. Yes, 5 numbers. Okay. 90 to 94 is 4 numbers. Oh man. And 97 to 99 is 3 numbers. Okay. All right, if you had to guess, what type of distribution would that be? I would say symmetric, yeah. Even though he's missing one more little bar over here on the side, or maybe even 2. Yeah, one more little bar. I would say that this is symmetric. Okay, so you had a lot of people score right here in the middle. In a symmetric, your average, like your mean and your median, are both living here. Okay, both the mean and the median will probably be right there in the middle. Okay, that's what happens with a symmetric graph. Okay, are we ready to move on to the second one? Are you guys better artists than I am? That you're putting a whole lot of time into these graphs. Okay, all right. So over here, let's do 60 to 64. There's only one guy. 65 to 69. I see 4. 1, 2, 3, 4. Okay. 70 to 74. 1, 2, 3, 4, 5, 6, 7. Did I do that right? Seven. 75 to 79. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. My graph goes up to like 12. Right here. Okay. 80 to 84. 1, 2, 3, 4, 5, 6. Let's see, 6. 6 is down here. 85 to 89 is 5 of them. I'm doing a very poor job at this bar thing. And then 1 down here for 90 to 91. What do you think that one is? What? Yeah, I would say symmetric also. Yeah, this one's pretty symmetric, but they're both symmetric in different ways, right? Which one has the data that's more consolidated? Like more shoved together? What's the second one? Second one, right? There's more, like the towers are taller because there's more data in just a few categories, right? They're not spread out as far, okay? So they're both pretty symmetric, but the right one is probably more consistent even because the bars are taller, but there's fewer categories. Does that make sense? Like we didn't even have any in the 95 to 99 range. And even the ones that we did have on the sides were only 1 in each category. So most of the people were right there even together. Does that make sense? Okay. So there's a lot of information that I can draw from comparing histograms. Holy cow. Just all of that stuff that I just said. These people are more consistent, right? The bars are taller, but they're more shoved together. Okay. These people are kind of all over the place. Yeah, the most people are here in the middle, but then it just tapers off from there. They're kind of a wide range of scores there. Okay. So that is comparing histograms. Yesterday we did only 1, but that's 2 histograms. All right, now box and whisker plot. We went ahead and took this guy, and we are making just 1 box and whisker plot. That's it, just 1 box and whisker plot. For this one, in example 4, we're comparing 2 of them, okay? So, box and whisker plot. They look like this. Negatively skewed, symmetric, positively skewed, okay? This is kind of like in a histogram, you would have a negatively skewed looks like this, right? Positively skewed would look like this, and symmetric would kind of look like this with your little bars in there and stuff, you know? bar, bar, bar. Okay, so if you compare that to the box and whisker plot, they kind of do the same thing, right? The majority of your data, that bar, is kind of shoved to the right on a negatively skewed. It's shoved to the left on a positively skewed. Okay, so kind of the same thing going on, all right? Now, we need to create a box and whisker plot, box and whisker plot, and we need what's called a 5-number summary. They will talk about the 5-number summary, okay? So these are the things that you need to look for. You need to look for the first number. You need to look for the last number, okay? Those are 2 of your 5 numbers. And then within there, you have a median, you have a quarter 1, and you have a quarter 3, okay? I like doing box and whisker plots because they're kind of easy, I think. So first number, last number, median, quarter 1, quarter 3. Okay, so when you're doing your first number and last number, just the first number, last number, make sure that they're in order. So we went ahead and put ours in order. If you need to pause this video, you can to write the numbers down. There's a 56 in here that I forgot about, so he's kind of slammed in there, so don't forget him. All right, what's your first number? 33. What's your last number? Perfect. Okay, 3373. All right, before I do anything else, I'm going to take and I'm going to draw a nice pretty line here. And I'm going to go 30, and I'm going to go maybe like, I don't know. Let's do 80. 30 and 80. I'm going to go just a little bit outside of our range. 30 and 80, okay? That means this middle one right here. What's exactly in the middle of 30 and 80, you know? What? 55. 55 would be here, okay? So that means like 50 is about here, 60 is about here, 70, and 40. Dang, I did that pretty good. That's not bad. Okay, so I choose a little bit beyond my first number, a little bit beyond my last number, and kind of label it so that it's equal increments throughout, right? I don't want to like my 30s to all be shoved together. I'm just drawing basically a number line, okay? We're going to put our box and whisker plot above this number line, so it's going to be all drawn out there, right? Box and whisker plot's going to go above this, all right? Now, we need to find the median. What's a median? The middle number, okay? A lot of people, when you guys do this, you start crossing off. Cross, 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 right? How many numbers do we have here? 24. What would be the middle number? Between the 12th and 13th number. Does that make sense? Okay? If you want to cross, 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 you can. But I'm going to say, since there's 24 numbers, it would be between the 12th and 13th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Right here is my median, right between 53 and 54. So what is the median? 53.5. 53.5 is going to be my median. So right here in the middle. I'm going to do this in a different color. Right there in the middle is my 53.5, right there. Okay? Now, how do you find Q1? Yep, you go between the first and the middle. All right, so I kind of do like a little brackety thing right here. Bracket, bracket, okay? I'm going to find the middle of those numbers. Now, how many numbers are in that set right here? 12. There are 12 numbers in that set, okay? So the middle number will be between the 6th and 7th number. 1, 2, 3, 4, 5, 6, and 7. Oh, yay! They're both the same number. So 46 is my Q1. Okay, now in the back half, that's how I find the Q3. Okay, there are 12 numbers there, so I find the middle of the 6th and 7th number. 1, 2, 3, 4, 5, 6, and 7. Between 60 and 62. 61. Okay, did I do that too fast? You find the middle, and then you find the middle again, and then you find the middle again. Okay? There are some weird rules, so I'm gonna add on to that here in just a second after we draw this thing. Okay, so first number is at 33, so I'm gonna put a dot up here at where I think 33 is, which is about there-ish. Okay, right above that line. The last number is 73, so I'm going to put a dot right about there, and I'm going to connect those two dots. This is where my box and whisker plot is going. The line that's down below is only there so that I can, like, space everything evenly. So this is 33, this is 73. Okay, now I need to figure out where my box is going to go. So my middle number is 53.5, which is about here. 53.5, okay? And then I have 46, a little over halfway, and 61, right there. Here is my box, and there are my whiskers. What type of distribution is this? We've got a lot of symmetric things going on today. Symmetric. They're symmetric. Okay. Sample size. Oh, that's just being, I'm like sampling that many people that have an average, whatever, of. And it's 478 from both of them. But I have to be No. You're doing You're doing these. Okay, so symmetric, good, yes. All right, now, this is something really interesting. There are the same number of numbers that are in this range right here as there are in this range. There are 12 numbers here and 12 numbers here, okay? Sometimes you will get a data set where the box is like all the way on one side. We'll maybe see that here in just a second. But remember that there's the same number of numbers here as there are here. They are evenly spaced on both sides, so that is why he is symmetric. Sometimes you'll have this bar all the way over here, okay? There's not less numbers over here, they're just closer together, and they would be more spread apart over here, okay? All right, before we move on, I'm going to do one more thing with you. Sometimes you have weird things happen. Let's say we have 7 numbers, okay? And I'm going to call my 7 numbers 1, 2, 3, 4, 5, 6, 7. There's my 7 numbers, okay? They're called X's, all right? Here's how you separate him out. Your smallest number is this one, assuming these are in order, right? Your biggest number is this one, okay? Where's your middle number? Do you have a middle number? If you have 7 numbers, do you have an exact middle number? Yes, this is my middle number, okay? So this would be your median, okay? Now, here's the weird part. If you have an exact middle number, you don't use that number to figure out your Q1, right? You put your bars there. So this guy is going to be your Q1 because he's exactly in the middle of those 3. You don't use that middle number to find your Q3 either. Okay, there's that. There's that scenario. Now, I'm going to change it and let's go back to like what we had with 24. We have 8 numbers instead. 8 numbers, okay? 1, 2, 3, 4, 5, 6, 7, 8, okay? Now my smallest number, assuming these are in order, is this one. My biggest number, assuming these are in order, is that one, okay? Do I have a middle number? No, so I average these 2 together. This is going to be my median, right? Now, since I did not have an exact middle number, where do I split them? In between the 2. So here, this is my range right here, and this is my range right here. So because there was not an exact middle number, I can put those 2 intervals right butt up next to each other. Does that make sense? Okay. So then how do I find the Q1? Average these 2 together. This is your Q1. And average these 2 together. This is your Q3. Okay. Did you know those rules already? Okay. All right. Some of my algebra classes coming up, they don't know that. So you guys are just brilliant. So if you feel like you need to write that down, that's great. But those are the rules. 7 numbers, 8 numbers. It depends on whether you have an odd number of numbers or an even number. Okay? All right. So let's go to the back side. Let's compare these 2, and then we'll be done. So each one of these boxes has 2 times 16 numbers in it. Okay? So we have an even number of numbers. So we're going to see that same thing again. Even number of numbers. 16 numbers. All right. So I want to do a box and whisker plot, and we're going to do these boxes right up on top of each other. Wow, that's a really bad graph. Let's start it at 0, and what's the highest number that we need to go to? This one has 41, this one has 51. Okay, so we need to cover all of it. Since we're graphing both of them together, we need to cover all of it. So should we do 0 to 60? Let's stop at 60. What's exactly in the middle of 60? I eyeball it and I find 30 is exactly in the middle, then I need to separate this into 3 pieces. 1, 2, 3. This is 10, 20, 30, 40, 50, 60. There we go. There's my number line. Okay, so I'm going to do my 2013 data, and I'm going to do my 2014 data down here in my 5-number summary. So I need a min, we'll just call it min, max, median, Q1, Q3. Wow, my lines are not straight. Okay, there we go. All right, so what is my smallest number for the 2013 data? Sorry, I'm going too fast. 7. 7's my smallest number. My biggest number? 51. Okay, smallest number for 2014. 3 and 41. Okay, so let's go ahead and make those little boxy things, whatever. Let's put the 2013 one on top and the 2014 one down below. So we're going to do 2 boxes right up on top of each other. So the first one, 2013, goes from 7, which is about right here, to 51, which is about right there. And I'm going to connect the dots. Okay? And then the other one, 2014, is going to go from 3, which is over here, to 41, which is here. Just like that. Okay, so now I've got my lines. Now I need to figure out where my other stuff is. Okay, so we have 16 numbers. So where would be the middle? You can cross them off if you want to, but what would be the middle of 16 numbers? 8 and 9. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. 8 and 9 are 27 and 27. So that means my median is 27. Am I going too fast? 27, 27, so the whole thing is 27. Now, I'm going to make my split. Since I had 2 middle numbers, my split's going to be here. There's my first range, and here. Here's my second range. Okay? So, now, I have 8 numbers here. The middle would be the 4th and 5th number. So, between 20 and 21. 20.5 will be that one. Okay? Over here, it will be between 30 and 30. Oh, 30 and 30. So 30. The average of 30 and 30 is 30. I should probably label these. 7, 51. I'm going to mark 27. And that's going to be a bar. And I'm going to mark 30. And I'm going to mark 20.5. Okay, there's that. So 20.5, 27, 30. Okay, good? All right, now I messed up because you guys weren't helping me because I decided it would be best to do these by ourselves and I messed up. So I have a 9 and a 20, which is going to complicate things, but whatever. 9 and 20 got forgotten until the last bit. So I've got to make sure I count those in here. Still have 16 numbers, so the middle 2 numbers are 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Is it 10 and 13 is my middle 2 numbers? If I average those together, 10 and 13. 10 plus 13 is 23 divided by 2 is 11.5, I think. Is that right? Yeah? 11 and a half? Yeah, it's got to be. Yep. Okay, so now I'm going to do my division right here and right here. So we have 8 numbers in there. It would be between the 4th and the 5th number, which would be between 6 and 7. 6.5. Okay? And over here between the 4th and 5th number, there's that range. 1, 2, 3, 4, and 5. 20 and 21. So 20.5. Okay, so my edge of my bar here is at 20.5, which is the edge of that bar there. 11.5 is here about, and 6.5 is about there. Okay, so let me label these 3, 41, 6.5, 11.5, 20.5. There's my 5-number summary. Now, from this box and whisker plot, can you see what's going on with these two? What do you think the 2013 data is? What? Huh? Negatively skewed for the 2013? I almost think that that might be pretty symmetric. He is kind of negatively skewed because he's over that way. Or positive, I guess he'd be positively skewed if he's over that direction. But I almost think this is a little bit symmetric. This one, though, would be positively skewed. Okay? And I can kind of see that down here, this second one, points scored these were points scored for football teams. There was fewer points scored per game in the 2014 games versus the 2013 games. Does that make sense? Yeah, I can see that. There's fewer points. The majority of the points scored are less on the lower end in the 2014 than the 2013. Okay? Box and whisker plots are really handy if you know how to make them and you know how to interpret them. They're really handy. Okay? Good? Anything else to add before we say goodbye? All right. Goodbye, people watching this video.